In this video, we will try to understand what an inductor is. If alternating current flowing through a coil, there is an EMF induced in it. The induced EMF across the coil is directly proportional to the rate of change of current with respect to time. Due to the property inducing EMF, all type of electrical coil can be referred as inductor. An inductor is an energy storing device which stores energy in the form of magnetic field. Now we will see what is inductance. As we already seen that the induced EMF across a coil is directly proportional to the rate of change of current through it. The proportionality constant in this relation is known as inductance. If the induced EMF is V and the rate of change of current is dIdt, then the relation is V versus dIdt. Now if L is the proportionality constant, then V is equal to L dIdt, and hence L is equal to V divided by dIdt. Basically, if current is flowing through a conductor, then a magnetic field is produced around it. The strength of this field depends upon the value of current passing through the conductor. For example, the amount of magnetic field created by 2 ampere of current flow is greater than the amount of magnetic field created by 1 ampere of current flow through a conductor. The direction of the magnetic field is found using the Fleming's right-hand thumb rule. The flux pattern for this magnetic field would be number of circles perpendicular to the direction of current. Now, if we wound the conductor in a form of coil or solenoid, it can be assumed that there will be concentric circular flux line for each turn of the coil. Now, if the current through the coil gets changed, the magnetic flux produced by it will also get changed at the same rate. As the flux already surrounds the coil, this changing flux obviously links the coil. Now, according to Faraday's law of electromagnetic induction, if changing flux link with a coil, there would be an induced EMF in it. Again, as per Lenz's law, this induced EMF opposes every cause of producing it. Hence, the induced EMF is in opposite of the applied voltage across the coil. When current flows through an inductor, then the induced magnetic field slowly increases with time and it stabilizes after some time. Then some energy will get stored in the form of magnetic field. When current stops flowing, then the magnetic field starts decaying and the energy stored in the form of magnetic field gets converted into electrical energy. So, the inductor is a temporary storage area for energy. This energy stored in the inductor resists certain changes in the current. So, the current in an inductor cannot instantly change. It always lags by a certain amount of time. There are two types of induction, self-induction and mutual induction. When alternating current flows in a coil, the time-varying flux is produced, and this varying flux will link with that coil itself, and as a result there will be EMF induced in the coil itself. This type of induction is called self-induction. When alternating current flows in a coil, it produces time-varying flux. As we have already seen, this time-varying flux may link with another nearby coil. Due to this flux linkage, there will be induced EMF in the second coil. This type of electrical induction is called mutual induction. Hence, mutual induction can be defined as the induction of EMF in one coil due to time-varying current flowing in any another nearby coil. This technology is used to make electrical transformer. Now, inductor behaves differently in AC and DC voltages. When a inductor is connected to a AC circuit, then one thing it does is it opposes the changing current flow. This property of an inductor is called inductive reactance and it is measured in ohms, just like resistance in a DC circuit. Please note that if an inductor is connected to a AC circuit, then current lags voltage by 90 degrees, about which I will discuss in detail in a later video. Also, inductor stores the kinetic energy of moving electrons in the form of magnetic field. This behavior of an inductor is quite different than of resistor, which simply dissipate energy in the form of heat. Energy stored in an inductor depends on the amount of current passing through it. Note that inductor is a passive component. I will discuss passive and active component in a later video. On the other hand, if an inductor is connected to a DC circuit, then it behaves like just a piece of wire. The wire by which the inductor is made provides a little amount of resistance in the circuit. Now, there are different types of inductor. Depending on their material type, they are basically categorized as follows. I hope you understand what an inductor is.